Okay, let's run through 5 through 11. Number 5, what is the meaning of 3 squared? So here I just wanted you to realize that 3 squared is 3 times 3. I didn't know how else to represent that, but that's such, so there you go. Hardest question in the world. Number 6, even more difficult. What is 5 to the 0? Remember what we said, anything raised to the 0 is 1. Okay, if you need a quick proof of that, raise 5 to any value. We'll call it squared to make it easy. 5 squared over 5 squared is 1, right? But we also know that 5 squared over 5 squared from the exponent rules, it means that we subtract. So we'd have 5 to the 2 minus 2, which is 5 to the 0, right? Which means 5 to the 0 is 1, okay? Anything raised, we can make this anything. In fact, if we wanted to be technical, we'd call it a letter like x, and x minus x is 0. So, in any case, almost anything raised to the 0 power is 1. Okay? Alright, let's see what's next. Number 7. Okay, let me do that on another page here. So number 7, 2 to the negative 4. What does that equal to? Well, remember we said when it's negative, that means that we flip it. So we have 1 over 2 to the 4th. And you can leave it like that, but some of y'all went further. You can have 1 over 16. I think the number one mistake that I saw here is that some of y'all started including negative signs here. Okay, this negative 4 just means you drop it to the bottom. Okay, so the rest of these are kind of follow the same sort of pattern. Next one, negative 2 to the negative 4. So this just means, again, negative exponent means we're going to do what? We're going to flip it. So now it's 1 over negative 2 to the 4th, which is perfectly fine. And that would be, again, 1 over 16. Okay. Note, this is in parentheses, so that's why we end up getting a positive 16 as opposed to a negative 16. Had this not been in parentheses, like in the next one, you'd have to include the negative sign. So the next one is negative 5 to the negative 3. Okay. Negative exponent, flip it. Okay, and it was actually sufficient to leave it as this. You didn't have to keep going, but if you kept going, this answer would actually be negative 125. And again, the reason why is if we follow PEMDAS, we have to do exponents before we start multiplying. This is technically a negative 1 here, right? So if we raise it to the third, we get 125 times negative 1. That's my answer. Okay. Do we have one more? We have 2 more. Okay, so let me just do the next 2 on the next page. So we have 1/4 to the negative 3. Again, negative exponents mean that you flip. So this is 4 over 1 cubed, this is sufficient actually. You could have left it like this, or you could have left it like this. But if you kept going, that's fine. If you kept going, this is 4 times 4 times 4, which is 4 times 4 is 16. 16 times 4 is 64. If you say numbers very quickly, people think you're smart. But again, it's just 3 4s, multiply them, you get 64. Okay, so big thing here, when it's negative, when the exponent is negative, we do the reciprocal, is the fancy way of saying it. The simplified way of saying it is that you just take what's on the bottom, it goes to the top, what's on the top goes to the bottom. Okay. Next one. Sorry, hold on. The next one's going to be 5 to the 10th times 5 to the negative 3. So the rule here is that if the bases are the same, then we just add the exponents. So this is 5 to the 7th. Okay? Now, what a lot of people did is they wrote it as 25 to the 7th, and that is a big no-no. Okay? Don't do that. The bases stayed the same. It's the exponent that changes. And make a note to yourself if you did actually end up doing that. That's a very common question that I see on future tests. Make sure that you're aware of that. Okay. Again, as always, make notes of where you made your mistake. Keep a notebook on the side of where the mistakes are made so that you can look out for those in the future. Okay? And I'll see you when I see you.